Hi guys, so we're going to go through predicting the products of double displacement reactions. So if you guys look on if you look on this video, you'll see how I have it set up where the YouTube is split screen to the left, the video notes on one note are split screen to the right. This is kind of how I imagine you guys going through this. If you have YouTube open, so this video, you'll have it open on one side and then the one note will be open on the other. So you should be able to see both of them. So I'd recommend setting it up like that for what we're about to go through. Alright, so today on this video notes, what we're going to be going through is predicting the products of double displacement reactions. Okay, so the goal of this, similar to what we learned yesterday, is predicting the products. Right, so essentially what is going to be these. Okay, so there's a method for this, and just as a review, these are the reactants. Okay, and then these are the products. Right, we are predicting the products of a double displacement reaction. So the other day we did learn how to identify double displacement reactions. Today we're going to learn how to, given reactants, find out what they are going to produce, which is a really useful tool in chemistry. So here are the steps for that. First of all, you need to determine the charge of all of the ions in the reactants. Okay, so we're determining the charge straight up, and then using that, we need to pair up the A, so the first cation will then bond with the anion from the second compound. Okay, so if we're looking at this setup up here, we have cation paired with an anion, and a cation paired with an anion. So essentially what's happening is the cation from the first one is pairing up with the anion from the second one. Okay, so kind of like this. Where the cation from the second one is going to be pairing up with the anion from the first one. So that's essentially all the basis for what's going to be happening in all of these. So after you figure that out, you do need to figure out the ratio of ions needed to make a neutral compound. So the same thing we've been doing throughout this unit. We always write the cation first, and then lastly, we balance the reaction. So let's go through a couple examples. So first off, we've got potassium carbonate. Okay, that's K2CO3. And then we have barium chloride. So in this, we need to know that we have our cation, and then our anion, and our cation, and our anion. So we determine the charges of each of these. Potassium is always +1. CO3 is -2. Barium is +2. And chloride is -1. Okay, so when we're going through these, we know that this positive, potassium, is now going to be paired up with chlorine, and this CO3 is now going to be paired up with barium. Okay, so we can do this. We know our potassium is going to be paired up with Cl, so K, and that's, actually let's do this down here real quick. So we have K, that's +1, and Cl, that's -1. If you guys did your crisscross, we know in this case they balance out each other the way they are, so it's just going to be KCl. Okay, plus, now we have barium and carbonate. So we have barium, that's +2, and we have CO3, that's -2. Okay, if you crisscross that, it's a 2 down there and a 2 down there. We know that we need to take a lower ratio, so it's just going to be BaCO3. Okay, they balance each other out. The +2 balances out with the -2. So it's just going to be BaCO3. So now the last step is we have to determine the coefficients in front of it. It's got to be balanced out. Okay, so in order to do that, we need to make sure that the potassium on each side balances out, that the barium on each side balances out, the CO3 on each side balances out, and the chlorine on each side balances out. So right now we have 2 potassium on the left. See, so K2. We have 1 CO3 on the left. We have 1 barium on the left in our reactants. And we have 2 chlorine on the left. Okay, so 2 chlorine, 1 barium, 1 CO3, 2 potassium. On the right, we have 1 potassium, 1 chlorine. We have 1 barium and 1 CO3. Okay, so 1 of each. So the only thing that we need 2 of is potassium and chlorine on the right. So if we add a coefficient of 2 in front, now that doubles the amount of potassium, so we have 2 of that, and we have 2 chlorine. Okay, so there we go. That's our balanced reaction for the first one. The rest of these, you don't have to write anything. We just assume that they're 1. If you want to write a 1, that's fine, but we just assume that they are 1 if you don't write anything. Okay, so let's go through a couple more. So in this one, we have iron bromide, and we have potassium sulfate. Okay, so first off, we needed to predict our products for each of these. Okay, so we know that bromine is -1, and there's 3 of those, so iron is +3. We know that potassium is always +1, and sulfate is -2. Okay, so we also know that our bromine is going to be paired up with potassium. And we know that our iron is going to be paired up with sulfate. Okay, because the positive gets paired up with the negative of their kind of like opposite counterpart. All right, so in doing that, we know that Fe, which is +3, it's going to be paired up with SO4, that's -2. So if we did our crisscross to figure that out, we should end up with Fe, let's scoot it over, Fe2, SO4, 3. Okay, plus, then we have K and we have Cl. So we have K and Br. Okay, so those are both +1 and -1. So they're going to fit together just 1 of each. K and Br. Okay, I originally wrote that as Cl, so I'm backtracking a little bit. So now we have to balance our reaction. So we have potassium, bromine, iron, and sulfate, where we're going to be taking a look at each of those. Okay, we have 1 iron on the left, so I'd already written that in, 1 iron. We have 3 bromine on the left to start off. We have 2 potassium and 1 sulfate. On the right, we have 2 iron, we have 1 bromine, we have 1 potassium, and we have 3 sulfate. So in order to balance those out, we've got to kind of make sure that we are figuring out what we need of each. Okay, so in this case, if we start out with balancing our, let's start out with our, let's start out by balancing out our potassium. So if we start out by balancing our potassium, we put a 2 in here. Okay, now we have 2 potassium on the right, and we have 2 bromine on the right. Okay, so now that throws off a couple other things. So now let's start off with balancing our iron. So if we balance our iron, we put a 2 over here. So now we have 2 iron, and we have 6 bromine. Alright, so that throws off some other things. So now we've got to get a couple other things in check. So if we wanted to balance out our bromine, okay, we kind of had to go back to our KBr. So if we go back to our KBr, we need to make this into a 6. So we made that into a 6. Now we have 6 bromine, and we have 6 potassium. Okay, now we're pretty close. On the right hand side, we just have to make this into a 3. We make that into a 3. Now we have 6 potassium. And we have 3 sulfate. It's all balanced out. Okay, so like you can kind of see there, it's not always like perfect. Sometimes you got to make adjustments. Sometimes you got to go back and you got to change something that you already made. So you got to kind of work with it until you get it balanced out and you have the same amount of them on both sides. Sorry, I had to move location. So now we're going to finish up. We're going to be doing our very last one. So we got to first start off by stating our charges for each of these. So while we have sodium is going to be +1. We have chlorine, which is -1. We've got calcium. Calcium's +2. And phosphate, which is -3. So then we know that we have to pair up the cations with the other anion and the anion with the other cation. Right? So the positive always goes with the other negative, and the negative always goes with the other positive. And then we have to work to predict our products. So our products are going to be Na, and so Na is +1, and phosphate, which is -3. So those go together, and we can do our crisscross to kind of say the amount so that it's even. But you could also know there's got to be 3 sodium to balance out with that -3 phosphate. So you're going to get Na3 PO4, okay, plus our other one, our calcium, is going to pair up with chlorine. Calcium, and then calcium is +2, and chlorine is -1. So we can crisscross it there, and you get CaCl2. Okay, and lastly, all we have to really do for this is make our chart to balance it out, because you need to have the same amount on both sides, what you're working with. So we have sodium, we have calcium, we have chlorine, and we have phosphate. So initially in this problem, we've got 1 sodium on the left, we've got 1 chlorine on the left, we've got 3 calcium, and we've got 2 phosphate. Okay, on the right we've got 3 sodium, we've got 1 calcium, 2 chlorine, and we've got 1 phosphate. Okay, so to start off, let's balance out our phosphate. Let's see if that could be something helpful to do. So we put a 2 in here, and remember we might have to change it, so we might have to go back later on, but let's start off with that. So now in balancing that out, now we have 2 phosphates, so that's good, but now we have 6 sodium. Okay, so now to go back on the other side, maybe we want to balance out the sodium that's available. So to do that, we've got to change it to 6. So changing that 6, now we have 6 sodium, but we also have 6 chlorine. Okay, so most of our stuff, well, our sodium and our phosphate are both balanced, but our calcium and chlorine are not balanced. So in order to do that, we've got to go to our other side. If we put a 3 in here, now we've got 3 calcium, and now we've got a total of 6 chlorine. So that's how we wrap that one up, and we can check our balancing is correct. We've got the same amount of each of them on both sides, and so that's how you predict the products and balance for a double displacement reaction.